Okay, so we're going to start with 1.5, the solving equations and inequalities by graphing. So we're going to do like kind of the base part of it today. So it says, how can you use a graph to solve this equation? So everyone in this room should be able to solve this by just algebraically, meaning, if you were solving this for x and you'd be like, okay, I'd subtract my 20 from both sides, and then I would divide by -3. You've done that for years and years and years now. So I'm just going to do that real quick so we have an answer to work with. So we'd subtract the 20 from both sides, which would leave us with a -15. And then I would divide both sides by the -3. And from there, I would know my answer. My answer is 5. All right, so like I said, everybody's done that. You've done that thousands of times, solving a one variable equation. But now let's look at it if we graph this. So if you're going to graph something like this, you're going to solve by graphing. We're talking conceptually here. I would personally never solve this problem by graphing because this takes like 5 seconds to do. But you're going to see problems in the future here that solving by graphing is way more efficient than solving it algebraically. So that's why we're kind of introducing it here. So again, this would be solving it algebraically. Solving by graphing is where you basically take the left side and the right side and you just graph each of them. So we're going to graph the -3x plus 20 as like a y equals equation. And we're going to graph the y equals 5. So again, that's just the left and the right sides of that equation. I'm going to graph each of them separately, and I'm going to look for where they're the same. All right, so this one here, y-intercept up at 20. So remember how mx plus b equations work. And a slope of -3. So that means it's going to go down 3 and right 1. And so because I do need this to be accurate, I'm going to plot all those points all the way down. So I'm going to go down 3 and right 1, down 3 and right 1, all the way till I get down to the bottom here. Okay, that's pretty good. So that's going to be my first line. And then my second line is actually the simplest one. It's y equals 5. That's a constant line. That's all the values where y is 5. So it's going to be just a horizontal line through 5. And so what we see there is these graphs do intersect, and the spot that they intersect is the solution. Now this coordinate happens to be 5, 5. But we only care about the x coordinate. So it's actually kind of a key concept going forward. Even though this is technically an x and a y value, since the problem was only about x's, there was no y's in the original problem, we only care about this number. Now this problem wouldn't matter because they're both 5 anyway. You'd get it right regardless. But it's important to realize that we are looking for the x value, which is where the 5 comes from. So all this really boils down to is you graph the two equations, you find where they cross, boom, there's your solution. Okay? So now let's look at one that's a little bit tougher. So this is an absolute value function. If I told you to solve this one algebraically, I wouldn't think many people would get it correct because this is not a very easy problem to solve by algebraically because of the absolute value. What you actually have to end up doing is you have to split it in two separate equations. One's positive, one's negative, and it takes a long time to solve. But solving it by graphing is actually super quick. So I'll show you what I mean. So if we graph this side, so this is just absolute value of x minus 4. That means it's shifted right 4 units. So we all should know that from earlier. It's shifted right 4 units. And then it's just your, up 1 over 1. I know these go by 2's, but it's the same concept, up 2, right 2. So this would just be your absolute value function that's sitting right there. So we can draw that in. Okay, so there's like the left side of the equation. The right side of the equation is just a y equals mx plus b. So your slope is 1/2 and your y-intercept is 1. So if you plot a y-intercept of 1 on here, and then use your slope of up 1, right 2, there's one solution already. And let's keep going because there's going to be another one. Up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. There's our other solution. So we can draw that line through there. And so what we see here is graphically we see there's two solutions because they cross at two different places. We want those x values. So here and here, just follow it down. So that's when x is 2. And that's when x is 10. And so those would be our two solutions in this case. So again, this is a problem that I absolutely would do by graphing. I can solve this problem by graphing faster than I could solve it by hand. And that's kind of the one of the things here is you got to realize what's more efficient. And in a lot of cases, graphing actually is. All right. Take a second on your own right now and see if you can graph and solve this one. See if you can find the solution or solutions. Okay, so let's talk a little bit about how I made my graph. So I did the negative 20 first because I always, whenever I see a constant number, to me that's the easiest graph there is. That just means a flat horizontal line at that number. So I drew the line through negative 20 first. And then I went to this mx plus b. I'm like, okay, I know this is my y-intercept is 10, my slope is 6. So I went up to 10, I started with my y-intercept. And then I realized, well, if I counted by 6, like I'd go up 6 and right 1, and obviously that's never going to hit this line down here. So instead I went the other direction. I went down 6 and left 1. Once again, this graph does go by 2, so you got to be a little tricky. If you mix that up, then obviously you're going to end up in the wrong spot. So down 6, left 1, all the way till I finally got to where it hit, which I saw happened at negative 5. A lot of this comes into just details. Like, can you follow all those little details, put it together? Like I said earlier, if I was actually doing this problem and it just said solve this equation, I would never solve this one by graphing because this one is super fast to just solve algebraically. But again, the idea here is there are definitely problems you're going to want to use graphing on, like what we're pretty much going to see from here on out. Okay, so the concept of the graphing is key because you got to do that to do the more difficult questions. All right. So again, though, negative 5 is just our answer because that's the spot where they end up crossing. Beauty of these problems, too, is you can just check them. If you plug negative 5 in here, it should work out. 6 times negative 5 would be negative 30, plus 10 is negative 20. So you know your answer is right when you get